one here is still loading.
Yeah, it's live here. So let me.
The whole one is supposed to stop, but it's still loading.
No, I'll close it. I'll close it. So check the link. You'll find the link. I'm sorry for the interruption. There have been a few technical hitches, so Joel is coming to continue with the lesson for today. So you can delete the other links on your status. Maybe you will go back. This one is
Okay, so welcome back. We are having some technical issues, that's why we are going on and off, but we are hoping that this time around it will just remain constant for all of us. Okay, so I'm picking another question and then we go through it. Still doing fractions and then we are taking some word problems that you may see them in BEC or things like that. Okay. So in the next question, it reads that in a school, 7/10 of the pupils like mathematics. How of those pupils who like mathematics are girls? If there are 240 pupils all together, in the school, how many girls like mathematics? Okay, so here too, the motivation for this question is that sometimes when you are solving questions and two set problems in mathematics BAC, it's not every time that the numbers of the two groups that are under consideration in your set problem will be given to you straightforward. Sometimes they will put it in a fraction form like this, in a statement like this, that you must work out to get your own numbers to solve your set question. So I'm reading over the question again. And it says that in a school, 7 out of 10 of the pupils like mathematics. Half of those people who like mathematics are girls. Now, if there are 240 people altogether in the school, how many girls like mathematics? So here it means that you have two different duties to perform. Before you can find how many girls like mathematics in the school, you must first of all know how many of the students actually like mathematics. And then from there, you can get how many of them are girls. So the first duty is people who like mathematics. So we first calculate people who like mathematics. Okay, so here to get the number of people who like mathematics, you must take the whole peoples in the school, and then we are given that to be 240. And then they are saying that out of these 240, 7/3 out of them like mathematics. So off simply here means multiplication. So we multiply that by 7 out of 10. So this simplifies to 24 multiplying 7. And then we multiply this. So if you have 24 here, you have 7 here, multiplying 7 times 4 should give you 28. That should be 8 here. Remember 2 times 7 is 14 plus 2 is 16. So then we have 168. But this 168 we have here, it's only for the number of people who like mathematics, meaning that this includes both boys and girls. Both boys and girls. But the problem is asking us to find how many of them are girls. And then the question also made us understand that half of the people who like mathematics are girls. So it means that to get number of girls who like mathematics it's simply going to be equal to 1 out of 2, because that is half. 1 out of 2 of its multiplication, the number we have here 168. Okay, so here too, from last week we were told that if you have multiplication of fractions, you check if a numerator can divide the denominator or the other way around. So here you can see that the 2 can divide 168. How many times? We check it out. So we have 2 here and we are dividing that by 168. So you pick the first two numbers under the division sign, that's 16. And 2 can divide 16 8 times. So we have our 80 here. 8 times 2 is 16. When we subtract, that should give us a 0 here. Then we move to the next number under the division sign, which is 8. So join that to this. 2 goes into 8 4 times. And then we have our 8 here. When you subtract, you have a 0 0. Meaning that the half of the 168 should give us 84. So it means that 84 of the total population in the school who are girls like mathematics, and that solves that problem. We take another question. Okay. So in this next question, we are told that Nat and Ken went out for lunch. They ordered a big bowl of bamboo to share. If Nat ate 4 out of 7 of the bamboo and Ken ate 2 out of 5 of the bamboo, the first question is how much of it was eaten all together? And then the second question says that how much of it is still left. So we want to find out. So two friends went to a restaurant or maybe a shop bar. They decided to order some bamboo to eat together. And then I can say there is a cheating ongoing. Maybe somebody eats faster than the other. One person has already eaten 4 out of 7 of the whole bamboo. The other person has also eaten 2 out of 5, and then both of them are satisfied now. So now I want to find out, when you pick the whole bamboo, how much of it has been eaten and how much of it are they leaving for the people to come and pack. So we are going to check out. So the first thing that you must do is to find the total fraction which has been eaten. The total fraction which has been eaten. So here it's simply going to be how much did Ken eat, how much did Nat eat. And if you are talking about this, then you simply have to add the two fractions. So the total bamboo eating is going to be equal to how much Ken ate. So going to be Nat plus Ken. So how much Nat ate and how much Ken also ate. And then we know that Nat ate from the question 4 out of 7. And then Ken also ate 2 out of 5. So this is addition. So we find the LCM. 7 and 5, the LCM should give us 35. Now from what we have already learned from last week and today, we take the denominator, check how many times it will divide this LCM, and that should give us 5 times. 5 times the 4, which is the numerator, should give us 20. And then we add 5 can divide 35 7 times, and 7 times 2 is giving us 14. So we have here 14. Now when I add 20 to 14, that should give me 34 out of 35. So it means that if we take the 4 ball of bamboo and we divide it into smaller portions of 35, Nat and Ken together were able to eat 34 of such small pieces out of the whole 35. So now the second part of the question is saying what is left. What is left? Okay. So I said that when we are considering it from this angle, we are looking at dividing the 4 bamboo into 35 different pieces. So the 1 full bamboo is the same as me saying I have 35 out of 35. But now I want to know how much is left. So it means that this 1 full, so we have 1 minus how much was eaten, which here is 34 out of 35. So this is also a subtraction problem. I have already indicated here that this 1 is the same as 35 out of 35. So it means that the LCM here is simply going to be 35. So here this 35 goes into 35 1. When I multiply that by that 35, I still get my 35 here. Minus, when I take this 35, goes here 35, multiplied by this should give me 34. So I have 1 out of 35. And you can clearly see from here, because if I have 35 pieces of something and I've already used 34 out of it, then it is just clear that what is left is going to be just 1. So that is how much of the bamboo is left. 1 out of 35. So I can say Ken and Nat together did a good job. They didn't leave the banku to rest. They really conquered it. Okay, taking one more. Okay, in our next question, it's a question on baking, and here we are told that a certain chef recommended that to make 6 meat pies, you need a half cup of sugar. So according to the chef, half cup of sugar is needed to make 6 meat pies. Amma decided to use only a third of the sugar to make it healthier. How much sugar did Amma use? When you look at this question, you'll be tempted to believe that Amma used just 1 out of 3 cups of the sugar. But this statement of the sugar makes us understand that we are linking this one to what the recommended size of the sugar is. So the recommended amount that we are supposed to use for these 6 meat pies, according to the chef, is 6, 1/2. That is half cup of the sugar. But Amma wanted to make it healthier, so she decided to use 1/3 of the recommended sugar. So in that case, it means that the amount of sugar used is simply going to be equal to what must be taken, which is the half times how much, how Amma decided to do hers. So she took a third. A third means 1/3, so 1 out of 3. of that. And then this take you to a simple multiplication problem in fractions, and then this should give you set to multiply that. You check if there is any divisions that can be done. If not, we just multiply the top number by the top number and then the down number by the down number, because this is a multiplication problem. So this gives us 1 out of 6. So it means that according to the chef, if this is a cup of sugar, then you are supposed to use half of it. So this is according to the chef. You must use this half. But Amma decided to divide this one into 2, and then now divide this side also into 3. So if I take this side, I divide this side also into 3. And then, so this was the half Amma was supposed to use, the down part, but she decided to use a third, which is 1/3 of the whole thing. So let's say Amma just used this part. So here, our calculations clearly show us that what we have done is correct. So instead of 1/2, Amma used 1/6. So you can see this is 1, 2, 3, 4, 5, 6, and Amma used just 1 out of the 6. But the chef wanted us to use 3 out of the 6, which is half. So that solves that problem too. Let's take the last one. Okay, in this last problem, we are saying that Carlos spent 1 hour, one whole number, 1/4 hours doing his math homework. He spent 1/4 of this time practicing his multiplication fact. Now the question is, how many hours did Carlos spend practicing his multiplication fact? And then what is this time in minutes? So we are going to find out how many hours he spent practicing, and then when we get that, we are going to convert it into minutes. So the first issue we want to find is how many hours or how much hours he spent, how many hours. So number of hours for multiplication is going to be equal to, the first thing you must do is to convert this mixed fraction into an improper fraction. So to do that, we multiply the denominator by the whole number and add the numerator to it. So this is 4 times 1, which is going to give us 4 plus 1, which is 5. So now we have 5 out of 4. And we are saying that out of this number of hours, he spent 1/4 of it. So we multiply this one by 1 out of 4 of it. Okay. So then this should give us, this is multiplication, so you multiply the top by the top and the down by the down, which is going to give us 5 out of 16 hours. So we say that he spent 5 out of 16 hours practicing. Now this one doesn't make sense, so they are asking us that what is this time in terms of minutes. So you know that to change hours to minutes, you must multiply that by 60. So we take this number of hours, so 5 out of 16, and we multiply this by 60 out of 1. So let's see if we can do some divisions. So I know I can see 4 can divide this one, and then 4 should divide here 1, 5. Okay. Then now this is left with, we have 15 by 5. This by this should give us 25, and that 2, this by this should give me 5 plus 2 is 7. So this is 75 over 4. So divided that, have 4 here, 75 inside. This goes here 1, and that should give me 4. When I subtract, I should get 3. Then bringing this one down here. Let's see how many times of 4 divide 35. We have 9 times, and that should give us 32. Remainder of 3. Okay, so here it means that we are going to get 19 minutes. We're going to get 19 minutes and some seconds. So that is how much time he spent working. So out of the 1 hour and 1 whole number, 1/4 hours that he spent doing the whole assignment, he spent approximately 19 or 20 minutes working on this multiplication fact. And on this note, we want to bring today's lesson to an end, and then we check for next week. So see you next week. Bye.